Well, welcome. Let's take a look at solving an SAS triangle. A triangle where I give you a side, an angle, and a side. And I designed this so there's going to be a trick to it. You know there's going to be a trick. Now, I've set up my triangle using the convention that capital A, capital B, and capital C represent the angles. Little a, which I don't have marked here, would be this side. Little b is this side, which is 19.7, and little c is 10. And I've given you capital A, the angle, that's 50 degrees. So I've given you a side, an angle, and a side. I'm asking you to find angle B. Well, you probably know there's no way to find it directly. In fact, your only move here is to use the law of cosines to find little a, side A here. So, let's use the law of cosines to find side A, little a, which would be this side right here. Here's the law of cosines, and we're solving for little a. We know side B, side C, and we know angle A, so let's plug in all those numbers. Well, that's what we get. Whip out your calculator, of course, and calculate A is 15.32. We'll round it to 2 places. So let's put that back on our triangle. Okay, now we know all the sides. We know little a, little b, little c, and we have angle A. We're still trying to find angle B. What are we going to do at this point? Well, you have a couple options. Notice you have a side and the angle opposite its side. You're looking for this angle and you know the side opposite. You might be tempted to use the law of sines. Some of you might suggest, well, you got all 3 sides here. You could use those 3 sides directly to find angle B using the law of cosines. Let's do both ways. First, the law of sine. First, we're going to use the law of sines, okay? So, setting up our ratio, we'll get this. Now, all we have to do is solve for sine B. Sine B is that. Do your calculation. On calculator is wonderful. And you get this. Now, if you take the inverse sine of this number, you'll know what angle B is. And we're calculating it to be approximately 80 degrees. All well and good. Now let's do the same thing using the law of cosines. So let's see if we can solve this using the law of cosines. And this is the version of the law of cosines we're going to use because this is the only one that has cosine B in it. Now let's rearrange this thing. So we're solving, so we solve for cosine B. We'll get this. Now on the right side here, these are all the sides of the triangle, and we know all 3 sides, A, B, and C, so we can calculate this. And we get negative 0.17424. Again, I'm rounding, but it's this negative number, negative 0.17424. Let's take the inverse cosine of that and see what angle that is. And we get approximately 100 degrees. Well, that's interesting because the law of sines says it was around 80 degrees. So, is the angle 80 degrees or 100 degrees? Well, we made a mistake here. We did something wrong. We did something wrong when we used the law of sines. Here is the rule. Never use the law of sines to find the angle opposite the longest side. Why? Because the angle opposite the longest side in a triangle, it might be obtuse. Triangles are only allowed at most one obtuse angle, and if it has one, it'll be opposite the longest side. Now, why does the law of sines have problems with that? Well, take a look at this. The sine of 80 degrees is approximately 0.9848. The sine of 100 degrees is also approximately 9848. That's interesting. As it turns out, all supplementary angles have the same sign. which means that sine can't tell the difference between an acute angle and an obtuse angle. Now, take a look at this cosine. The cosine of 80 degrees is 0.173648. But the cosine of 100 degrees is negative 0.173648. The absolute values are the same, but for this one, notice it's a negative number. Cosine can tell the difference between an acute angle and an obtuse angle. Obtuse angles will have negative cosines. So cosine can tell the difference. So just remember this rule: never use the law of sines to find an angle opposite the longest side, and you'll be absolutely fine.